What is going on, guys? Welcome back. In this video today we're going to build a tic-tac-toe game including an unbeatable AI using Pygame in Python. So let us get right into it. Alright, so I always like to give you guys a motivational preview up front so that you can see what we're going to be working on in this video, what we're going to end up with at the end. And this is going to be the final result. A simple tic-tac-toe game, a 3x3 grid, and I can click somewhere here to make my first move. This places an O, then the computer places an X, then I can place an O here, computer places an X here, I can block the computer, I can make another move, and it's a tie. I can reset, and I can play a little bit worse this time, so I can do this, and instead of blocking here now, I can click here, and I lose. And since tic-tac-toe is a very simple game, this AI is unbeatable. It plays perfectly because tic-tac-toe, if you play it perfectly, you cannot lose it. You can only get a tie. You can win, of course, if the opponent doesn't play perfectly, but tic-tac-toe is not something that you can lose. There are certain rules that you have to follow and you will never lose. And this AI does exactly that, but it's not hard-coded. It does that with an intelligent algorithm. So this video is going to be quite interesting for beginners and intermediate programmers. You will learn how to work with Pygame, and you will learn how to implement the Minimax AI algorithm. Alright, now before we can get started with the coding right away, we need to make sure that we have two packages installed on our system. First of all, Pygame, and second of all, NumPy. Now to do that, open up your command line and type either pip or pip3 depending on your operating system, install, and then Pygame and NumPy. These are the two packages that we need to install for this video today. And in addition to that, we're also going to import the core Python module sys. And we're going to do that in order to use the exit function so that we can terminate the application. And of course, in addition to that, import Pygame and import NumPy as NP. So what we want to do first is we want to initialize Pygame. We want to say Pygame init, and then we want to define some constants. And these constants are going to be very relevant throughout this code because they're going to define certain things that are very important for displaying the board and the moves and the players and all that to basically handle the geometry. We're talking about sizes and colors and proportions and widths and heights and so on, and rows and columns, just static or constant numbers or values that are going to be relevant throughout the code. So what we want to do first is we want to define some colors. We want to have the color white, which is going to be a triple of RGB values. So 255, 255, 255. So RGB maxed out. Gray is going to be equal to 180, 180, 180. Then red is going to be equal to 255, so maxing out R, which is red, 0, 0 for green and blue. Green is going to be obviously 0, 255, 0, and black is going to be equal to 0, 0, 0. So white is going to be the default color, black is going to be the background, green is going to be the win color, red is going to be the lose color, and gray is going to be the tie color. That's why we have these different colors. Then we can say here proportions and sizes or something like this. And we're going to define the width of the window. The width of the game is going to be 300. The height is going to be 300. And the line width for the grid is going to be equal to 5. We want to have 3 rows, 3 columns, so a standard 3x3 grid as we saw in the preview. Then the size of a square is obviously going to be equal to the width of the full screen divided by how many columns we have, or rows, doesn't really matter if it's the same. And the radius of a circle, of basically the player icon, is going to be the square size floor divided by 3. So just so we can fit it into a square. And the width of a circle, so of the circle line, you could say, is going to be 15. And the width of a cross, of the lines, of the X basically, is going to be 25. So these are constants. You can change them, of course, but instead of having to constantly use these values, we're going to just provide the constant names here. So that makes everything much easier. What we want to do now is we want to create a screen object. We're going to say screen is equal to Pygame display, and then set mode is going to be getting the width and the height as parameters here. So this is going to initialize the 300 pixels times 300 pixels screen. And then we're going to say pygame.display.setCaption. And we're going to set the title Tic-Tac-Toe AI. And then we're going to fill the screen with black color, which is in our case 0, 0, 0. Or not just in our case, black is defined by RGB 0, 0, 0. All right, so we have an empty black screen now. What do? We define a board. Now, we don't plot it yet. We don't display it yet. We just define it as a structure. This is why we need NumPy, because our board will by default be a NumPy array full of zeros that has the shape board rows and board columns. So 3 by 3 in this case. So we have this board, and 0 basically means that this field has no player on it. No one has done anything on this field. It's empty. It's unused. Now what I'm going to do here in this code now is I'm going to keep everything very modular in functions so that we know what individual functions do, and we can just use them as functions instead of having to write the code of them, so that we know easily what we're doing in the respective function calls. So one function is going to be the function draw lines. And this function literally just draws lines. It draws the lines of the board. And it does that in a specific color. By default, this will be white. So if we don't provide anything, it's going to be a white color. But if the game is won, it's going to be green. If the game is lost, it's going to be red. If it's a tie, it's going to be gray. So by default, it's draw lines. It's color white, but we can pass different colors as well. So what we're going to do is we're going to say for I in range, we're going to go from 1 to the amount of rows. So we actually only need 2 lines. We need 2 lines horizontally and 2 lines vertically. And what we are going to do here is we're going to say pygame draw line screen color. So on the screen, draw a line with a color. And then we define the trajectory of the line. So where does it start? Where does it end? And we want it to start here, 0 and square size times I up until width and square size times I. So basically from the start to the end, from 0, the first position, to width, the last position. And we want to also do it the other way around, or on the other axis. So we want to do square size I, 0 to square size I, width. Or actually, in this case, height. Doesn't really matter because it's the same, but yeah. So this is the draw lines function. We're going to call this line, we're going to call this function every time we want to draw the lines again. So when we start the game, when we win, when we have a tie, when we lose. And we also want to pass, of course, the line width here so that we know how strong the lines shall be, or how wide. All right, so that's a quite simple function. The next function is draw figures. Now, draw figures basically checks what kind of information is on the board. So do we have all zeros? Then we don't have to do anything. But if we have ones or twos, ones indicating the player and twos indicating the AI, then we need to mark these positions on the board. So we are going to say here, sorry, draw figures. Color again is going to be white by default. And we're going to say now for row in range, board rows, for column in range, board columns, so 9 times. We're going to say if board row column is equal to 1, then we have to plot a circle because that's the player. If it's 2, we need to plot, or we need to draw an X or a cross. So in the case of 1, we're going to say pygame draw circle on the screen with the given color, and it's going to have the following center or position, you could say. It's going to be column times square size to get to the right column, plus square size half, because we want to be in the center of that specific square. And then we also need to do the same thing for the width, or for the row. So we're going to say row times square size plus square size floor divided by 2. That is the center, and the radius is going to be the circle radius, and we're going to pass the circle width as well as the line width, so to say. Now I think I'm blocking this. Let me just move my camera to the top right here so it's not blocking the code all the time. So again, this is it. We have a circle. We draw the circle on the screen with the color. The center of the circle is moved to the respective row and column, to the respective cell or square. Then go to the center of the square, horizontally and vertically. That's the center. And from there, draw a circle with radius, circle radius, and with line width, circle width. That's basically it. Otherwise, if at this position we have a 2 instead of a 1 or a 0, we say Pygame draw line, and we want to draw 2 lines that are basically crossed. So we want to do line on the screen again, color, and the starting position is column times square size plus, and this time we don't want to go to the center, we want to go to one corner and down to the other corner. So we want to do square size floor divided by 4. And actually, what am I doing here? Oh yeah, this is what we want to do. And for the row, the same thing, square size plus square size divided by 4. That is the starting position. From you go into a cell and then you go to 1/4 of the size, so in the top left corner basically, and then you want to go to 3/4 of the side to the bottom right corner. That's the basic idea here. So that's the start position, and the end position will be column times square size plus 3 times square size divided by 4, so floor divided by 4. And then row times square size plus 3 times square size floor divided by 4. That's the idea here, and then we can copy this because that's just one line. What we now also want to do is we want to go to a mix of the two. So we want to go from, we want to go from column square size and then square size divided by 4. And here we want to do now row times square size plus 3 times square size divided by 4. And the end position is going to be column square size plus 3 times square size divided by 4. And then row square size plus just square size divided by 4. That should work, I guess. I hope. Because we're going from top left to bottom right and from top right to bottom left. I think that's correct. All right, so we have the draw figures function. That's that. And then we have some simple functions just to do some basic work. And we want to have them as functions so that we don't have to think about what we're doing. We just have names and we know what the functions do. So one function could be mark square. We want to pass a row, a column, and a player. And all this does is it takes the board, add position row, add position column, and it sets it equal to player. That's it. That's what this function does. Another function could be, or is, available square, row, column, and this function returns if the board at this position, row and column, is equal to 0. So we can see if it's available, because if it's 1 or 2, there's already a player there, or an AI. Then we can also define a function is board full to see if there's actually any space left on the board. So we can say check board is going to be equal to board by default. Now, why do I do that? Because sometimes I might want to apply this operation not on the actual board, but on a fictional board, on a future possible board. This will be important in the AI algorithm. So by default, it's going to be board, but not always. So I'm going to say for row in range board rows, for column in range board columns, if at this position, row and column, there is a 0, we can return true. If at any position there is a 0, we return true. But if we iterate over all of them and there is no 0, then we return false. All right, and then we have one of the most important functions, checking if someone has won. And the rules in Tic-Tac-Toe are quite simple. 3 in a row, 3 in a column, or the diagonals is a win. Of the same player, of course. So we can do check win. We have to check for a specific player. And we also have the checkboard again being equal to board by default, but not necessarily always. And we want to do now for column in range board columns. We want to check if checkboard 0 at this specific column is equal to player. And then I can copy this and copy it again. And here we want to do, of course, 1 and 2. So if in the same column I have 3 times the same player, or this player actually, then this player won. Return true. Elif, or actually not elif, we need to do another loop, but I can copy this. I can basically copy paste this, and I can say now for row in range board rows. And all I have to do is I have to change this to row 0, row 1, and row 2. In this case, we also have a win. And finally, if checkboard 0, 0 equals player, and now let me copy this as well. And this, so if we have 0, 0, then also 1, 1, and 2, 2, so one diagonal. If that's the case, we also return true. And also if we have 0, no, actually 2, 0, yeah, 2, 0, 1, 1, and 0, 2. So we can say 0, 2, 1, 1, and 2, 0. That is the other diagonal. And this is also a win. Otherwise, if none of this is true, we return false. There is no win. Not yet. At least. All right. So that is now the very basic stuff here. This is just a setup, so to say. We have now the constants, the geometry. We have a function to draw lines, a function to draw the players, a function to mark a square for a specific player, a function to check if a square is available, a function to check if the board is full or not, and a function to check if a certain player has won, given a board. The intelligent part now happens in the minimax function. So def minimax, and this function takes as a parameter the minimax board, a depth, and a parameter is maximizing, which is a Boolean. And what this function now does is, this is how the AI makes a decision. Now I can make a more detailed video about minimax, but the basic idea is the following. Every state of the board can be assigned a value or a score. So how good is this position for the AI? How good is this position considering the setup? So of course, if the position is a winning position, so the game is already won, then that's the best case scenario. But we want to determine, given a certain setup or given a certain board, what is the score for this particular board. And we want to do that not just in the current situation. We want to also know, okay, from this position onward, what could happen? What could I do? What could the opponent respond with? And what could I respond to the response of the opponent, and so on? So you want to predict what can happen and assign scores to the different scenarios. So this is going to be a recursive function. I'm going to explain how it works while we're coding it. But again, I'm not going to focus too much on giving you a perfect explanation here. The goal is to implement this. If you want to have a detailed video about Minimax, I can make one. I'm going to explain the idea, but I'm not gonna, focus too much on making sure everyone understands this here. So the important thing when you have a recursion is you want to have a base case. You want to have something where you return a specific value and not just another recursive call. You want to reach the end at some point. Now, in our case, the end is going to be you lose, you win, or there's a tie. That's the end. So that's the base case, you could say. So we can do that right away at the top of the function. If check win, and remember 2 is the computer, the AI, 1 is the player. So if 2 wins, given the minimax board that is passed to the minimax function, then we can return the score for this position where the computer wins. For the computer has the best score possible. That's like infinite reward. You won. It's not just a good position, you won. That's the best thing that can happen. So what you want to return here, or one thing that you could return here, is an infinite value, float inf. That's the perfect score. That's the best thing that can happen to you. Now, another thing would be, what happens if player 1 wins, given the minimax board? So not just that player 1 has a good chance of winning, player 1 already won. That, of course, is the worst thing that can happen. So what you want to do here is you want to give a negative infinite reward. So that's the worst thing that can happen. That's the best thing that can happen. And also, if the board is full and no one won, that is the definition, of course, of a tie. I'm going to pass the minimax board. And a tie is completely neutral. It's not good. It's not bad. It's exactly 0. That's what a tie is. So these are the base cases. At some point, we're going to reach those base cases. Now, what's the Minimax algorithm in general? The Minimax algorithm can be maximizing or not. And the reason you don't want to always maximize the score is because the computer also has to guess what I'm going to do. So what a computer does, when I make a move, the computer thinks about what happens if I make this move, or this move, or this move, or this move. And how does it do that? I make a move, and the computer says, let me just open my paint, I can explain this to you better if I visualize it. Let's say we have this board here, and I make a move now. I make this move here. Now the computer considers all possibilities. This is a possibility, this is a possibility, this is one, all these are possibilities. And in order to figure out how good a possibility is, how good an action is, it takes the action and then it simulates what would it do? What would the intelligent AI do in my position to respond to this move? So I have now, again, the possibilities here to respond to this move. And out of those, what do I think will the AI do next? So it goes back and forth. It plays itself, then it plays me. It plays itself until there is nothing to play anymore. So to consider this option, it says, okay, I can do this. Then he could do this. Then I could do this. Then he could do this. Then I could do this. Then he could do this. Then I could do this. And then he could do this. Oh, here I lose. But also, I could also do something like this. Or actually, it's my turn. I can do something like this. Oh, this is good. So it considers all the possible outcomes. It goes through all the possibilities and assigns scores to them. And then it picks the route where it is most likely to win. That's the perfect way to play it, you could say. Yeah. And these are the base cases. So what we're going to do now is we're going to distinguish between two cases. If is maximizing and if it's not maximizing. So if it's maximizing, it's simulating its own move. What should I do? So the computer is asking itself, what should I do? What's the best move for me? So how do we do that? We should do something like the best score is something negative so that we can easily beat it. The baseline is negative 1000, for example. And now I can consider all the moves that I can make given the current board. So I can say for row in range board rows for column in range board columns. Try all the possibilities and evaluate the scores. Now, how do we try all the possibilities? By saying, first of all, consider only the rows and columns, or only the cells that are actually available. So if minimax board, or actually we do have a function for this, don't we? Oh, no, it only works with board. So we're going to do it like this here, keep it simple. So minimax board row column. If that is equal to 0, if it's available, I can simulate what happens if I make a move there. So I say minimax board row column is equal to 2. It's the computer that places the cross there. Then, to calculate the score of this action, we recursively call the minimax function. So we say minimax, and we call the function on minimax board, and we increase the depth by 1. So we go deeper into the function. And now, since in this move I was maximizing, but the next move is the move of the player, so I need to play it the other way around. I need to figure out what would the player do. And the player would do what's the worst possible thing for me. The player tries to decrease my score. So to simulate what the player would do, I have to think like the player, so I have to actually make the move that's worse for me. That's the worst for me. That's the idea here. So it goes back and forth until it reaches a base case. And it does that for all the different possibilities. And then once we're done with the evaluation, we go back to setting row and column to 0, as if nothing ever happened, so that we don't manipulate the board. And we say that the best score, we update the best score by saying the maximum score between the score that we had right now and the best score that we already have. That's the idea here. And of course, in the end, we return the best score. And this now here, we can actually copy paste this. The other case, simulating what the player would do, is the exact same thing, just the other way around. We start with a positive score, and we're trying to minimize the score. So we're trying to, because the score is always from the perspective of the computer. The computer doesn't like to lose. So if we minimize the score, we're making the best decision for the player, the worst decision for the computer. And of course, we want to set this to 1, not to 2, because now we're the player, not the computer. And we want to do the same thing, but this time here, we also want to do is maximizing true. I'm going to go through it one more time when we've coded it out, just so you get the understanding. And the important thing here, we want to minimize now. Okay, so to recap quickly, what do we do? The important thing is to evaluate how good a move is. Now, if a move gets us to winning, now from the perspective of the AI, if a move gets the AI to win, that's the best thing that can happen. That's infinite reward. If a move gets the AI to lose, that's the worst thing that can happen. Infinite negative reward. If a move results in the board being full without anyone winning, that's a tie. That's a completely neutral move. It's completely okay. There's nothing good, nothing bad about it. So what the AI does is it tries to think about it that way. Looking at all the free fields that I have, all the free cells, all the free squares. What happens when I choose this one? What would the enemy do? What would the opponent do? And how do I evaluate what the opponent will do? By calling the function recursively from the other perspective. From calling it with is maximizing false. Then it pretends to be the player. Okay, I want to minimize the score for the AI. What would I do? I have to consider all the open fields and consider what the AI would do as a response. So again, we go back. What would the AI do if I do this? And it goes back and forth. Recursion is not too easy to understand if you're not used to it. So if you're a new programmer, if you're a beginner programmer, don't try too much to wrap your mind around this. It can be a bit confusing and overwhelming. But it's basically calling the function recursively back and forth from the different perspectives until it reaches a win, a loss, or a tie, to then go back to the initial call to return the score of the whole interaction, you could say. That's the idea. I'm not going to explain any more here. If you want to have a detailed explanation, let me know in the comment section down below. I can try to explain it theoretically in more detail. All right, so this is that, and we can also then define a function best move, which uses the minimax function to actually decide what the best move is. Here we can say best score is equal to -1000. The move by default is going to be -1, -1. So move being the cell or the square that we want to choose. -1, -1 is invalid. And we're going to say for row in range board rows, for column in range board columns. If board row column is equal to 0, then we're going to consider, or the AI is going to consider, what happens when the row and column are set to 2. So that's actually the same thing that we do here in the minimax function, but we do it here initially. So we say score is equal to minimax. We need to start somewhere. We need to call the minimax the first time here. So we call it with the original board, we call it with a depth of 0, and we call it with not maximizing, because this is already our move here. That is now, this function call evaluates the possibilities of the opponent, of the player. And then we can say, again, considering or having considered that, go back to 0, leave the board unchanged basically, and continue with the rest. And if the score that results here, that this action results in, is better than the best score that we have, then we update the best score to be equal to the score, and we update to move to be equal to a tuple of row and column. So these are the coordinates, you could say, or the position. This is the position that you want to play. Now, if the move is now no longer equal to -1, so if a best move was chosen, then we mark this respective square. So we take the move 0 and the move 1 coordinates, and we place a 2 there in this row and column, and we return true. Otherwise, we return false. And now we basically have almost everything. One more function that we need is the restart game function, but then we have everything and we just need our main loop. So we're going to define restart game. And restart game is just going to fill the screen with black color. It's going to draw the lines again with default color white. And we're going to say for row in range board rows, for column in range board columns, board row column equals 0, resetting everything to 0. That is our restart function. So how do we get started? This is now all we have. Again, just as a quick recap, we have constants, we have drawing functions for lines and figures, we have creating squares and checking squares and seeing if the board is full, seeing if there's a win, and the Minimax AI logic. And then we have considering, the function that determines the best move for the AI, and a restart game function. Now, how do we start the whole process of actually doing something now? Because these are only functions. The first thing we want to do is we want to draw the lines. We want to draw the lines for the grid. Then we want to define which player is starting. So player is going to be equal to 1. And then we're going to say that game over is equal to false. The game is not over, it just started. And then we're going to start our main loop, while true. And here's going to be our game logic. For event in pygame event.get, if the event type is equal to pygame.quit, we're going to exit the application or the game. If, on the other hand, the event type is equal to pygame.mouse button down, so when we do a click and the game is not over and not game over, then we're going to get the coordinates of the mouse click to determine which cell was clicked, and then we're going to set, if it's free, our symbol there. So we're going to say mouse x is going to be event.position 0. Now, this is going to be a coordinate. We need to have the cell. So what we want to do is we want to floor divide this by the square size, and we want to do the same thing for the mouse Y, just that we go with position 1 here. And then we're going to check, is this square that I clicked on available? We're going to say if available square, and then mouse Y, mouse X, because row is going to be on the vertical and column is going to be on the horizontal. If that square is available, we want to mark the square with the player symbol. So we want to mark mouse Y, mouse X with player. The player is 1. If we have won by doing that, so if the game is over and we won, then we want to say game over equals true. And we want to say that the player, or not in this case, just game over equals true. And if that's not the case, so if we didn't win, then we want to change the player. The player is going to be equal to player modulo 2 plus 1. Now, why do we do it like that? We can also just say 1 if 2 and else 1. But this basically is just a mathematical way to turn a 1 into 2 and a 2 into 1. That's it. That's the fancy way of doing that. Because 2 modulo 2 is 0 plus 1 is 1, and 1 modulo 2 is 1 plus 1 is 2. So that's the idea behind that. If the game is not over after this move, then we're going to get the best move from the computer, if best move. So we're going to check, did the computer make a move? And by calling the function, the computer also makes a move. So if there is a move that was made, we're going to check if this resulted in a win for the computer, if check win 2. And if that's the case, we set game over to true. And we change the player again if that's not the case. So player equals player modulo 2 plus 1. So again, we check, is the square available when I click on it? If yes, mark the square, check if I won. If not, let the computer play. Computer makes a move. If it makes a move, check if the computer won. If not, I'm on my turn again, so I can click again. Or it's my turn again. Then if not game over after all of this, so if the computer made a move, I made a move, or if I made a move, the computer made a move, and no one won, we can check if the board is full, because that would be a tie. So we can say if is board full, then game over is finally true as well. And what we can do then is we can say after the event type, we also want to say if event type is not mouse button down, but a key down. If I press a key on the keyboard, what I want to see is if this key that I pressed, so if event key is equal to pygame and then key R for reset, then I want to restart the game. And then game over is false and player is 1 again. And finally, outside of this game loop here, what I want to do is I also want to do if not game over, draw the figures every single time. Remember, this is a while true loop. It's running all the time. So if the game is still going on, I want to draw the figures. I want to update the board information to also be displayed, to also be drawn onto the screen. Otherwise, if the game is over, I want to draw in different colors. I can check again who won. So if the player won, I want to draw the figures in green, not in gray, in green. And I also want to draw the lines in green. Then I can copy paste this. Elif, if the computer won, I want to do the same thing in red. And finally, if the game is over, but I didn't win, the computer didn't win, then we want to do the same thing in gray. That is a tie. And at the end, every time I want to do a pygame display update. All right, so that was quite a bit of code. I'm pretty sure I will have made some mistake here. I don't think this is going to run first time, but let's see. we have our game. I click somewhere. Okay, it results in a tie. I knew it. There's a problem. So let me see what the problem is. The problem is, if not game over. So it is set to game over at some point. Let me just double check with my prepared code. We have a sysexit here. We have an if available square, mark square, if check win, game over true, player is changed, if not game over, if best move, there you go, there you go. That is also fine. That is also fine. So I think the problem is not in the main loop. The problem has to be probably in the is board full or check win function. So we have row column equals 0, and I think that's a problem. We need to turn this into false. There you go. Is board full needs to be changed to return false in this case and true in the other cases. I think that's the issue. So there you go. Now it seems to work for the most part, but the X's or the crosses are not displayed in the desired width. Let me just see if I can lose. There you go, I can lose. Okay, I cannot win, of course, because the AI will not let me win. Let's go to the part where these are drawn. Yeah, of course, here at the end we need to also say cross width. So I can run this again. There you go, now it works. Okay, so maybe we can change the minimax function to let us to allow us to win. Maybe we can just confuse it by reversing minimum and maximum. So I can do a min here and a max here, and let's see what happens then. Then I'm allowed to win, as you can see. So that works. But of course, it's unwinnable if we use the correct algorithm. So yeah, this is how you implement a tic-tac-toe game in Pygame using an AI that's unbeatable. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.